Hello, I'm Amber. I'm from the Ohio State University. And I'm going to tell you today, well, today I'm going to give you a bit of an ad, but in my defense, this ad is a free thing that is meant to help you. So hopefully that's okay with you. I have been working on a collection of notebooks, a resource for people to learn about microlensing. And I should probably firstly acknowledge the people that have helped me in this. So my beta testers, Ali, Arjun, Dylan, and Katarina, who has been guiding me and provided lots of good feedback for this. And yes, okay, so let me just tell you, and I figure out how this works. Where do you point it?
You mean the points?
No, where do you point it to go to the next slide?
You can't. You have to do the
Oh,
arrow.
sorry, I heard you wrong. I thought you said the arrows don't work. Because they don't.
Okay. Okay, with the mouse.
Flag. Okay, cool, good. Okay, so what is this course? So the goal of this course really is to be a tool for people that are new to the field at the level of about a graduate student. So it's for you, but it's for you in the sense that it's supposed to make your life easier when it comes to training your new students. And it's meant to be just a collection of all the wisdom that we have learned as that we have gathered as a community, the pitfalls in certain modeling or whatever, and like historic theories and context that like is really hard to get when you're new to the field. So I've also tried to make a collection of like a code base of things you can do in Python. Basically, it's very Python centric, but it is meant to be a showcase of research tools, if not a training device for research tools. So the gist of it is there's meant to be a collection of links, resources, but also exercises and text that teaches them everything they need to know to dive into research in microlensing. So how does it work? It is mostly Jupyter notebooks, and there are lots of things in the Jupyter notebooks, but it is designed to work like a choose your own adventure style syllabus. So you read a notebook, you don't like a section, you skip the section. You finish the notebook, you get to pick which notebook you move on to next. So there are recommendations to try and make the story cohesive, but it is really meant to be consumed in chunks just as you see fit. So there's a lot of content here, but it's not content that everyone has to finish start to end. It's not really intended like that. And it's self-directed, so it doesn't need a lecturer standing there telling you how to move on from one step to another. It's all covered in the notebooks themselves. They have a very conversational tone, and it kind of talks you through what's going on. And it's got some assistance tools too, like progress tracking and stuff, because if you're jumping around these notebooks, you want to be able to tell how much you've done, what you've done, those kinds of things. So installation, it's pretty simple. I did keep this still including GitHub stuff because I think that's kind of useful to know. So you clone the repo, you create the environment using the YAML that's been provided from the Microlensing Guide to the Galaxy clone, and then you activate the environment. So that's it, that's the installation done. If you use this YAML, it all works perfectly. If you don't use this YAML, I would recommend Python 10 or Python 12, or you're going to start running into some issues with Matplotlib. Sorry about my fonts. I am new to Macs and I did not realize that there are naughty fonts. So here we go. Launch it. So how do you launch? This is pretty simple. You just launch a Jupyter notebook like you normally do. Just make sure you're in the environment first, and then it should all work just fine. So Jupyter notebooks, yep, great idea. Jupyter Lab, also a great idea. IDEs, wish that was in the box, but they work, but there is missing functionality in a lot of IDEs for embedded videos. So if you do use an IDE, you'll have to click links for any videos that exist. So how does it work? Navigation. Okay, so you can just, in Jupyter Notebooks, go through, find the notebook you want to open, click it, open it. It's pretty basic. The README itself directs you first to the introduction notebook because that's a very logical place to start. There are in-text links that link you to other notebooks, like this one here that says, do you try the microlensing errors notebook? You can click that, it opens the notebook in your browser, and then you've moved on to your next thing. All right, beyond that, bottom of every notebook has a next step section, which recommends to you where you might want to go next in your journey. So that's pretty simple. And then, okay, so how do you stop from getting confused and skipping a step? At the top of every notebook, there is a section that tells you things you probably should have covered before you tackle this notebook. So if I'm going to assume knowledge, it is mentioned in the top of the notebook. Sorry. Ooh. And this is my progress checklist. So this is where you go. It's a notebook of its own where you go. You can load these progress checklists and you can tick them off. Your progress is saved. And so then when you reload the checklist you're after, all of those ticks are still there and you can get a feel for how far through each notebook you are. And there's also another checklist for how far through like exercises you are as well. One of the more interesting parts of these notebooks is the interactive plots. I think they're quite cool. They let you kind of learn microlensing intuition by playing with like some of the parameters in different equations and then seeing how that affects other stuff. So these are two of the interactive plots that I've got in the introduction notebook. And they're kind of just showing you how different lens and source distances change, what the lens looks like angularly and what it looks like physically. Which it makes sense to all of us, right? But when you're learning it, it's a really nice thing to help you along. This is an interactive plot that kind of tries to teach you about when caustics are resonant and how they split off and when they're really far away from the lens axis and when they come in together close to the lens axis and like how close they get to the center and when they go far away. So the gist is just you change S and Q and you see how that affects what caustics look like. And then there you've also got the critical curves. All of the exercises. So there are a lot of exercises in these notebooks. The imports are at the beginning of the notebooks. Pretty simple. You click the cell, run it, and then you should have all the imports. The exercises are all in these gray boxes. I've tried to keep the exercises pretty simple. So they are mostly written for you if it looks tedious. I don't make you do plot x-axis 10,000 times. X-label, sorry. So I've done a lot of the tedious stuff and the exercises are all just there to really validate the knowledge that was in the text, but also to the text, the code that's already in there is meant to showcase things that are a little bit more difficult that maybe you don't want to tackle when you're learning, but you want to know exist. So it's nice to know that you can query the NASA exoplanet archive, but you don't really want an exercise that says to do that with no guidance. So the NASA exoplanet archive, this is a good example. So in this exercise, the user is asked to plot the planets onto this plot. So the archive is loaded, they make the plot, and then they put the planets onto this. It's just teaching them about log axes, astroquery, those kinds of things, but it's also teaching them about demographics. So yeah, and then if it's too hard, if you're not really a Python person, but you do still want to learn about microlensing, that's fine. There are sample solutions in the exercises folder. They're all named logically, but each of the exercises also has a link on the exercise title, which takes you, it will open the solution for you directly in your browser. Okay, so code base. These are the kinds of things I've tried to cover in the notebook so far, just to get a feel for all of these things. There's some other stuff too, but this was just all I could think of. I would love to include other things, and I would especially love to include more microlensing codes, but you know, I'm one person, so I've done what I can. So these are the notebooks that are completed so far, and by completed, I say they would have been completed if I didn't get sick 2 days ago. I've put in here the approximate duration of how long these things take. That's the duration if you're doing the exercises. They're a lot quicker if you're just reading the content and watching the videos. I've got an introductory series that involves these 4 things. An introduction that just kind of mostly takes you through how the notebooks works and some general stuff about microlensing. Something that's more on exoplanets or brown dwarfs, demographics, the overlap, things like that. Remnants and dark matter. So a lot more on black holes and, you know, the history of microlensing. And then there's the eras one, this is kind of following the format of the Gaudi 2012 paper that we all got thrown at us when we were learning. I also have these notebooks here, single lens, binary source, and just details on modeling. This is what I've got covered so far. There's lots of good exercises. So if you finish the notebook collection as it is, you should be able to fit a single lens event and a binary source event. And in a couple of weeks, hopefully you should also be able to fit a whole season in a parallelized whole season. So fingers crossed. Coming soon, binary lenses. It's a big job. I'm working on it. There's a lot of degeneracy to cover, so it's taking me. Oh, sorry, I should say How do that? I should say, this QR code on here is the QR code for my main branch. So everything that is completed, everything that's in the main branch is completed. This is a course that you can now distribute to your students. But I have a lot more stuff in development. So if you're interested in things that aren't in the main branch, you can visit this branch, my dev branch, where I have all of the stuff that's still being worked on, extra content, but there might be a half-finished exercise in there or a sample solution missing or something. Okay. So ticket items. These are the things that I would love to get finished in this project. So there's a lot of stuff. I would love feedback for one. At the moment, it's a pretty small circle of people that have been able to give me feedback on this, but I would love a lot more now that they're more complete. And I would also really like some notebooks of things you're working on. If you've got a project that you've been working on, you have a really great notebook that describes it. I see no reason why I can't link to it in these if that's something that you're willing to do. I would love to incorporate that. And I also am not an expert in all of the subfields of microlensing, so I would really like to pass the baton off to people that are the experts to contribute notebooks in those subfields. So, for example, dual field interferometry, which I know nothing about. So it would be really nice if at this point I could kind of be editor more than author. Cool, I'm on time. I would love to be editor more than author, but I suppose I will keep chipping away at this if no one else wants to help. If you also have any great analysis examples, like if you think you've done a really cool piece of analysis that you've not seen before, I would love to see that because I would like to show it to people that are learning the field. And if you have any cool figures or interactive plots or something, I'd also love those. So if you're willing to share, please share. So that is the end of my talk. And this is my reviews that I have so far. So I will take questions now.
Question 5. Hi, but this is fantastic. So if you want to stick in other reviews, so I can't wait to teach it to my 30 lab students.
Okay, cool. Thank you. I need a name though. Come check with you later.
So are you running it on a hosted server where if you get 100 random undergrads at once, it won't crash?
I thought about it. It was on my issues log in GitHub for a really long time. I thought that was how I wanted to take this, but I have changed my mind. I don't think that's the way to go. I think that it is useful to learn how to use GitHub. It is useful to learn how to use environments. And I just think that it is worth doing that setup step. So I don't think I will host it, but I am willing to be talked out of that if you really think it's worth hosting. Yes. Yeah, I also am not, it's not in my skill set to host it. So I would love someone to help me with that if they think that's a good idea. Hey, Rachel.
Yeah, well, just as a point, are you aware that some of the big software companies, including Google, have grants available to education people to do hosting of this kind, including working with somebody on their team to help you do that?
I was not aware, but I did know that many courses came under the Roman Pitt grant, so I wasn't sure if I could double dip on money for this. So, yeah.
You raise it carefully.
Okay. Raise carefully, get more money. Got ya.
I think it's time to continue. I would just say you should contact Rach because she can good with microlensing source that contain already a lot of.
I've seen all of microlensing source and I link to it in loads of places, and I also still give glossary and it's in my resources section, and I meant to ask, sorry.
All right.